Now this is in the standard form here. We can replace it with e. So the value is e cube. So we will get 3 square minus 4 into 3 divided by 3 minus 2. So 9 minus 12 divided by 1. So the value is minus 3. This is the standard form, x to the power n minus a to the power n divided by x minus a, which can be written as n into a to the power n minus 1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to revise a very important chapter, limits and continuity of the function. From this chapter, you will get 1 mark question, 2 mark question and 1 6 mark question. So total, we will get 9 marks from this chapter. So we have very important for 6 mark question. We have 2 important derivations. So you can expect any one of them from 6 marks and 2 mark 1 question from the continuity and 1 simple question to find the limit of a given function. So let's see the questions here. Evaluate limit x tends to 0 of the function sin ax by bx. We know the standard limit, that is limit as theta tends to 0, sin theta over theta is always equal to 1. We have derived it. So whatever the theta takes the value here, the same value should be in the denominator. Now when you have sin ax, we need a in the denominator. So for that purpose, I'll multiply and divide by a here. So I can take a and b outside the function because they are constant. So therefore I can write it as a by b limit as x tends to 0 sin ax divided by ax. So now this limit takes the value 1. So therefore the value of the limit is a divided by b. Next, limit x tends to 0, 1 plus 3x to the power 1 by x. We have a standard limit, that is limit x tends to 0, 1 plus x to the power 1 by x is equal to e. So whatever the value of x is there here, the same should be in the index. So here I'll write the limit here by multiplying 3 here. I'll multiply and divide by 3 here. So multiply and divide by 3. Now we can apply the limit here as x tends to 0, 1 plus 3x to the power 1 by 3x whole cube, 3 times the same limit. So now this is in the standard form here. We can replace it with e. So the value is e cube. Next, evaluate limit x tends to 3, x square minus 4x divided by x minus 2. So we will get 3 square minus 4 into 3 divided by 3 minus 2. So 9 minus 12 divided by 1. So the value is minus 3. X tends to 0 sin 4x divided by 2x. We know the standard limit. So we need to have the denominator as 4x for the numerator and 2x for the denominator. So therefore here we'll write limit x tends to 0 sin 4x. I'll multiply 4x and I'll divide by 4x here. And for sin 2x, again I'll multiply 2x, I'll divide by 2x. We can apply the standard limit for the quantity inside the bracket. Here x and x get cancelled, 2 1s are 2 2s are. I can take 2 outside the limit. Limit of this function is 1 divided by limit of this function is also 1. So 1 over 1 we'll get. So the answer is 2. Next, evaluate limit x tends to minus 3 x cube plus 27 divided by x plus 3. This is the form of a standard limit. So let's write this as x cube minus 3 whole cube divided by x minus of minus 3. Now we can apply the limit as x tends to minus 3 here. This is the standard form, x to the power n minus a to the power n divided by x minus a, which can be written as n into a to the power n minus 1. So the value of n is 3, a is minus 3 to the power 3 minus 1. So you will get here 3 minus 3 whole square, which is 27. Next. So here we have 2 marks question. So your 2 mark question will be basically on evaluating the standard limits, or they'll give you the questions from the continuity of a function. That is to find whether the function is continuous at the given point, or to find an unknown value whether or whenever the function is continuous at a given point. Now let's see the question here. Find k if the function f of x e to the power 2x minus 1 over x if x is not equal to 0, and k if x is equal to 0 is continuous at x is equal to 0. Whenever the function is continuous, the limit of the function should be equal to the functional value at the given point. That is, according to this question, limit as x tends to 0 f of x should be equal to f of 0. Now clearly they have mentioned you that at x is equal to 0, the value of the function is k, and limit f of x when x close to 0, that is not equal to 0, the function is defined as e to the power 2x minus 1 over x. So here I can write this as limit x tends to 0, e to the power 2x minus 1 by x is equal to k. And here it is one of the standard limit here. So I will multiply 2 and divide by 2 here. Now it takes the standard form of the limit whose value is equal to 1. So therefore here when you apply the limit taking 2 constant outside, you will get the value as 1. So therefore we'll get the value of k as 2. Next, find k if the function f of x to the power 4 minus 256 by x minus 4, x not equal to 4, and k when x is equal to 4 is continuous at x is equal to 4. Again we will take the same definition. Limit of the function as x close to 4 should be equal to f of 4, because they have said you the function is continuous at x is equal to 4. Now therefore, limit as x tends to 4, then the function will be x power 4 minus 256 divided by x minus 4. And what is f of 4? At x is equal to 4, the value is equal to k here. Now this can be written in the form of a standard limit, that is x power 4 minus 4 power 4 divided by x minus 4, that is equal to k. Now if you apply the value of limit as x tends to 4 here, the value will be 4 into 4 to the power 4 minus 1. So therefore k will be equal to 4 power 4, which is nothing but the value of k is 256. Next, show that the function f of x 1 plus 3x to the power 1 by x at x not equal to 0 and e cube at x is equal to 0 is continuous. To show that the function is continuous, we need to show that the limit of the function should be equal to the functional value at the given point. So let us find out. Clearly they have mentioned here f of 0 is equal to e cube. If my limit value is also the same, then the function is continuous. So let us apply the limit as x tends to 0 to the function 1 plus 3x whole to the power 1 by x. We have already done this problem before, so we will multiply 3 and divide it by 3 here. So if you apply the limit for this function here, taking whole cube, we will get e as the value and outside we have q. So clearly we are getting limit of the function as x close to 0 is equal to f of 0. So therefore we can say the function is continuous at x is equal to 0. Now very important, two theorems for 6 marks. They'll ask you the theorem limit x tends to a x to the power n minus a to the power n by x minus a as in a to the power n minus 1, and the standard limit theta tends to 0 sin theta by theta is equal to 1. So any one question they'll ask you for the 6 mark. So let us see the proof of this theorem. We have 3 cases here, taking n as positive, n as negative and n as rational. Now let me consider case 1. taking n as positive integer. So n is positive integer. So now let me consider here x to the power n minus a to the power n. So from binomial theorem we can write the expansion in this form: x to the power n minus 1, x to the power n minus 2, a to the power n, x to the power n minus 3 a square plus etc. plus a to the power n minus 1. So now here divide throughout by x minus a, then we'll get x to the power n minus a to the power n divided by x minus a. So here dividing by x minus a, it get cancels. We are left with the term x to the power n minus 3 a square plus etc. to the power a to the power n minus 1. Now apply the limit as x tends to a on both sides, then we'll get here limit x tends to a, x to the power n minus 1, x to the power n minus 2a, x to the power n minus 3a square plus etc. plus a to the power n minus 1. Let us apply the limit as x tends to a, then it will be equal to a to the power n minus 1, x to the power n minus 2 becomes a to the power n minus 2 plus a, you will get it as a to the power n minus 1 only. Here a to the power n minus 3 a square becomes a to the power n minus 1 plus a to the power n minus 1. So now you have a to the power n minus 1 n times. So therefore the value will be equal to n into a to the power n minus 1. So thus we got the answer for the first case, that limit of the function is equal to n into a to the power n minus 1. Now let's take the limit for negative integer, that is case 2. Let us take n is equal to minus m. Now we know the standard limit x tends to a, x to the power n minus a to the power n divided by x minus a. Replace n by minus m here, then it will become limit x tends to a, x to the power minus m minus a to the power minus m divided by x minus a. So limit x tends to a, 1 divided by x power m minus 1 divided by a power m divided by x minus a. So then on evaluating this, we will get a to the power m minus x to the power m whole divided by x minus a into x power m into a power m. Let me take minus outside, then I'll get limit as x tends to a. Here the numerator is x power m minus a power m divided by x minus a, and I'll separate the limit as x tends to a for 1 divided by x power m a power m. Now this is the standard limit whose value will be equal to m into a to the power m minus 1. Now here we'll get 1 divided by a power m a power m. So a power m becomes a power 2m. So then I am left with here minus m a to the power m minus 1. 2m when it goes to the numerator, we will get minus 2m. So I am left with minus m a to the power minus m minus 1. What is minus m I have taken initially? I have taken it as n. So replace it by n. Then I'll get n into a to the power n minus 1. So for the same limit, if n is negative integer, we are getting the conclusion as n into a to the power n minus 1. So thus case 2 is also finished. Next we'll consider case 3. That is, we'll take n in terms of rational numbers where q is not equal to 0. So now let's take the standard limit as x tends to a, x to the power n minus a to the power n divided by x minus a. Change n value as p by q, x to the power p by q minus a to the power p by q divided by x minus a. Let x to the power 1 by q is equal to y and a to the power 1 by q is equal to b. So this implies x is equal to y to the power q and a is equal to b to the power q. Also, as x tends to A, this implies y tends to B. Now let us change the limit to the variable y and b. So then it becomes limit y tends to b. X to the power 1 by q is taken as y. So this will become y power p. Similarly, we'll get b power p divided by x and a can be replaced with these two terms, y power q minus b power q. Now to obtain the standard form, we need y minus b in both numerator and denominator. So let me divide it by y minus b. Then what happens? We will get limit as y tends to b, y to the power p minus b to the power p divided by y minus b. Here y to the power q minus b to the power q divided by y minus b. Now we will get the standard limit form. So we can write this as p to the power b p minus 1 q b q minus 1. We can separate p by q. Then I'll get the power of b as p minus 1 minus q plus 1 minus 1 cancels. Then I'll get p by q b to the power p minus q. Let me take q as a common factor here. I'll get b to the power q. Here I'll get p by q minus 1. Now here you can see b to the power q can be replaced as a and p by q can be replaced by n. So therefore here I can write this as n into a to the power n minus 1. So therefore here also for the standard limit x to the power n minus a to the power n by x minus a, as x close to a, the value is n into a to the power n minus 1. So here you need to prove all the three cases, that is for n positive, for n as negative and n in terms of fraction. So this completes the proof. Next we have another very important theorem. Prove that limit theta tends to 0 sin theta by theta is equal to 1. So for this we need a geometrical proof. So let us consider a unit circle with center O and let me consider an angle AOB. AOB. Let us draw here AD perpendicular to OA and extend OB to meet D. Then draw one more line BC perpendicular to OA. So join AB. So whatever construction you have done, that you need to write in the form of a description. That is, let us consider unit circle with center O. Angle AOB is equal to theta in terms of radians. Let us take theta we have measured in anti-clockwise and let theta be positive. Now draw AD perpendicular to OA, extend OB to meet D, then draw BC perpendicular to OA, join AB. Now from the figure we can clearly write here area of triangle AOB is less than area of sector AOB, which is less than area of triangle AOD. So you can clearly see this is your triangle AOB, this is your sector AOB. So here you have the line A and B and this is O, and outside this is the bigger triangle whose area is maximum. So from this we know the area of a triangle is half into base into I. Now for the triangle AOB we can write this as half into base is OA, height is BC. Area of sector is given by theta by 360 into pi r square. But here theta is measured in radians, so we'll write theta by 2 pi into pi. Radius we will take it as OA square. So we will get it as OA square less than half into base into height. Now in all the three terms here, half is common. OA can be taken as 1 because it's unit radius. So then by taking half, here we can get cancels with pi and this is theta here. So taking half outside, we are left with BC less than theta less than AD. Let me take this as equation 1. Now from triangle, we'll take a right angle triangle COB. COB. Sin theta is opposite side by hypotenuse. That is BC divided by OB. OB is actually the radius of circle. Its value is 1. So we'll get BC by 1. So we can write BC is equal to sin theta. Similarly, from the triangle AOD, we can write tan theta is equal to this triangle opposite by adjacent, that is AD by OA. So here also we'll get AD divided by 1. So therefore I can write AD is equal to tan theta. Now this you can take it as 2 and this you can take it as 3. 2 and 3 if you substitute in equation 1, we'll get sin theta less than tan theta. Next is divide throughout by sin theta. Then we'll get 1 less than theta less than 1 by cos theta. So here we need to divide by sin theta. Tan is sin by cos. When you divide it by sin get cancelled, we are left with cos theta. Let us take the reciprocal. So taking reciprocal, we'll get cos theta less than sin theta by theta less than 1. Now let us apply limit throughout as theta tends to 0 here. Cos theta less than limit theta tends to 0 sin theta by theta less than limit theta tends to 0 1. Apply theta as 0, we'll get cos 0 less than limit theta tends to 0 sin theta by theta. So 1. Cos 0 is also 1. So this is also equal to 1. Now from the both side we have 1. So clearly we can conclude that limit theta tends to 0 sin theta by theta is equal to 1. Now since we have taken theta in positive, we are getting that limit of sin theta by theta as theta tends to 0 is equal to 1. Now let us take theta as negative. What happens if theta is negative? So consider limit theta tends to 0 minus sin theta by theta minus theta. So now this can be written as limit theta tends to 0 sin of minus theta divided by minus theta. So if you change minus theta to any x, it will imply the same concept, that is limit sin theta by theta. The theta value should be same here. So and here it is same. So therefore it is of the standard limit whose value can be taken as 1. So therefore for any theta, that is whether theta is positive or negative, we can conclude that limit theta tends to 0 sin theta by theta is always equal to 1. So this is the conclusion. So these are the two important theorems that you can expect any one of them for 6 marks from this chapter. Again, a very important chapter and easy to score. So let's look at the next chapter revision in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.